Hi, it's Professor Logue again. In this screencast, we're going to look at single sign-on. The objective that we're dealing with here is that of explaining just what a single sign-on can do. It's the second of three objectives that we have for Chapter 11. So on this slide, we've summarized what's in the content in the textbook in this bulletized list. We start off by identifying that one of the biggest problems that users face today is once they've created all these wonderful passwords with sufficient complexity and length, mixing upper and lower case, not using words in the dictionary, maybe using a passphrase. After they've got all these, they have so many that they, across so many accounts and platforms, that each one requires a unique name and password that they just can't keep track of all of them. They cannot commit them all to memory. And given that many of these require them to change them on regular frequency at a regular frequency or periodicity, it becomes even more difficult. So what happens? We're all human. We end up writing them down or using weak passwords so that we can remember them, or using the same password across multiple accounts. So this is a huge problem, and it's led to the creation of identity management as one possible solution. By identity management, what we mean is using a single authentication credential called a single sign-on, or SSO, that's shared across multiple networks. So when networks are owned by different organizations, that's a problem because you're going across well-defined boundaries. So to be able to do that, there's a new protocol developed that follows what we call the Federated Identity Management Protocol, or FIM, F-I-M, Federated, meaning a federation or a connection of organizations that share these credentials, Federated Identity Management. So if we do this right, single sign-on holds the promise to reduce the burden that users face with regard to remembering all these usernames and passwords, and lowers it down to one password, kind of like a password vault, if you will. So how does this work? Well, in identity management, you have several large internet providers that have to support it, but only for their own particular suite of services and applications. So as an example, as it says here, Google, a Google user, can access all the features on the Google site across this federation of applications: the Gmail, the Google Docs, the spreadsheets, the calendar, the Picasa photo albums, just by entering a single username and password. That's the Google solution. Another example is the so-called Windows Live ID. This was introduced over 20 years ago as the so-called .NET password. The name's been changed since that time to Microsoft Passport Network, and then finally it's now being known as Windows Live ID. This is designed as to be a single sign-on for web commerce. We also have Windows Live ID authentication process. This requires a Windows Live ID, which in turn requires a user to create a standard username and password. They use this across their various platforms, including Windows Live, Office Live, Xbox Live, MSN, and other online services that they use. So let's look at federated system technologies. In this slide, you can see these three key protocols, if you will. These are often the terms that you'll see used in various questions on the Security Plus accreditation exam. So you should know them. This table is convenient because it groups what the essential information is for each one. There's OAuth. This relies on token credentials. And what happens in OAuth, its description here is Open Source Federation Framework. So it's not a protocol per se, but a framework for a protocol. It relies on token credentials, and as it says here, what happens is a user will send their authentication credentials to some server. You see kind of a diagram that depicts the scheme over here. Here's our user operating this browser. You can see that there's a website, two websites. So these are the two web servers, A and B, that they might be trying to communicate with. But before they're allowed access, there's a secondary application server that maintains the authentication information and actually does the authentication. So the OpenID credentials are shared with these, this particular OAuth authenticator, which then can then validate that this is an authentic user. So as it says here, a user sends their authentication credentials, that's this line, to a server, it's actually this line, to a server, and also authorizes a server to issue token credentials to a third-party server. These token credentials are used in place of transferring the user's name and password. These aren't generic tokens, but are specific sources, resources on a site for a limited period. Also, I forgot to mention the other two entries in this table, the OpenID Connect. In this scenario, we provide user authentication information, and this one is authentication protocol that can be used in OAuth 2.0 as a standard means to obtain user identity. So it's another method of authentication. And then there's the Shibboleth, which is an open source software package. The key words here are open source for designing the single sign-on. So this uses Federation standards to provide SSO and exchanging attributes. So single sign-on, federated system technologies, things to remember here, again, are the name, OAuth, which is the framework, not a protocol, and then OpenID Connect, which can be used in accordance with the OAuth framework as a means to obtain user identity, and then the Shibboleth to provide single sign-on and exchanging attributes from an open source package. So that concludes the second objective, looking at single sign-on. Again, what's important is to understand what single sign-on is, to know what this term means. Federated identity management is about sharing credentials across multiple organizations, and the reason why we have single sign-on. And then, of course, it'd be important to know maybe a few examples of it. So that concludes objective number 2. I'll see you in the next video.